We all know the drill. You type in a new password and the screen flashes red. You need an uppercase letter, a number, a special symbol. So you hammer away, adding exclamation points and random digits until the system finally accepts it. Then, right when you finally commit that bizarre string of characters to memory, a prompt pops up. Your password expires in 90 days. You have to start all over again. For decades, the cybersecurity industry treated this rigid, user-hostile framework as the unquestioned gold standard of protection. The prevailing logic was that if a password was hard to remember, it must be hard to crack. Ignoring how actual human beings behave created a massive vulnerability. By forcing users into these rigid constraints, we built a security model that was structurally prone to failure. That model broke on June 5, 2012, when the social networking site LinkedIn suffered a massive data breach. Initial reports stated the hackers stole passwords for nearly 6.5 million accounts. The true scale was much worse. Years later, LinkedIn revised the total, discovering that the same breach had actually compromised over 100 million email addresses and passwords. The theft was carried out by a Russian hacker named Yevgeny Nikulin. It took an international manhunt and an Interpol warrant executed by Czech police in Prague to finally capture him. The infiltration of the network was the first step. The deeper shock for the tech industry was how effortlessly those millions of stolen passwords were being unscrambled into plain text. The data leaked from this hack provided empirical evidence that our legacy password rules were essentially broken, and in some cases were actually assisting the attackers. To understand the engineering failure behind the hack, we look inside LinkedIn servers. They used a process called hashing, which scrambles a readable password into an unreadable string of code. If stolen, they get meaningless gibberish. The mechanical flaw was that LinkedIn failed to use salting. Salting injects random data into the hash, ensuring that even if two users have the same password, their scrambled codes look completely different. Without a salt, the scrambled hashes remained static. This allowed attackers to use rainbow tables, massive lists of matching scrambled and unscrambled passwords. They compared their list against LinkedIn's database, reverse engineering the passwords in seconds. Mathematical encryption is useless if systems leave a static, identifiable shortcut for attackers to bypass it. Mathematics alone didn't break these accounts. Human behavior did. These rainbow tables only work because hackers can predict exactly which words we choose when we're forced to meet machine requirements. When forced to meet complex requirements, humans look for shortcuts. People default to context-specific words, like the name of the website. Thousands used variations of LinkedIn. Users also rely on dictionary words and common phrases, stringing them together just to satisfy mandatory length rules. And then there's the sequential logic flaw. When the system forces you to reset your password every 90 days, you don't invent a completely new one. You take your old password and simply change the number at the end from a 1 to a 2. Attackers know exactly how we think. They don't guess passwords randomly. They run automated scripts designed specifically to exploit these predictable psychological shortcuts. Imposing arbitrary complexity didn't create randomness. It created a highly structured psychological roadmap that hackers used to unlock millions of accounts. The fallout reached the U.S. Congress. Lawmakers like Mary Bono Mack and Patrick Leahy pointed out that because users often reuse the same login for their bank accounts and sensitive government systems, a single social media leak had become a threat to national infrastructure. In response, the National Institute of Standards and Technology, or NIST, released their updated Special Publication 863B guidelines. The guidelines introduced major changes. First, they advised eliminating arbitrary periodic password resets, which only encourage weak habits. Second, they dropped forced complexity requirements, ending the mandatory use of special symbols. Third, systems must now proactively block new passwords that appear in known breached databases. This was a complete shift in philosophy. Security experts stopped blaming users for bad passwords and started demanding that systems accommodate human nature instead. The modern solution is the passphrase. Systems now encourage you to use up to 64 characters of normal storytelling, stringing together simple words, including spaces. A short password crammed with special characters is mathematically brittle and easy for a computer to crack. A long, simple sentence creates raw cryptographic strength that brute force attacks cannot bypass. True digital security isn't achieved by forcing humans to act like machines. We get better protection by designing intelligent systems that work in harmony with our psychology.